So hello everyone, in this audio class we will discuss the 20 most important questions from the chapter Atmospheric Circulation and Weather Systems NCERT Geography book. These questions will be very much important for your upcoming KVS and NVS Geography PGT interview. So let's get started with the question number 1. What is atmospheric pressure and why does it decrease with height? So atmospheric pressure is the weight of the air exerted on a unit area of the Earth's surface. Atmospheric pressure is measured with a mercury or aneroid barometer, and standard level pressure is 1013.25 millibars. The pressure decreases with height because the density of air decreases upward. Near the Earth's surface, gravity compresses the air, making it denser. As altitude increases, the amount of air above decreases, so the pressure falls rapidly. 1 MB for 10 meters of ascent in lower atmosphere is the decrease rate. For example, a mountaineer climbing the Himalayas experiences lower air pressure and low oxygen at higher altitudes, making breathing more difficult. Next question, why is atmospheric pressure highest at sea level? Because the entire column of air lies above sea level, and gravity compresses the air most strongly near the Earth's surface, making it denser and increasing pressure. Next question, why are all pressure readings reduced to mean sea level before drawing weather maps? So atmospheric pressure naturally decreases with altitude. If we compare pressure recorded at different elevations without correction, the comparison becomes misleading. Therefore, meteorologists reduce all station pressures to mean sea level. This allows pressure differences to represent true atmospheric conditions, not merely differences in elevation. Suppose one weather station is located at Kolkata near sea level and another at Shimla, a high latitude. Even under the same weather conditions, Shimla records lower pressure because of elevation. Reducing both values to sea level makes comparison scientifically valid. Next question, what are isobars? So isobars are lines joining places having equal atmospheric pressure reduced to mean sea level. Next question, what is the pressure gradient force and why is it important in wind movement? So the pressure gradient force is the force produced by the difference in atmospheric pressure between two places. Air always moves from high pressure to low pressure due to pressure gradient force. The greater the pressure gradient, the stronger the the greater the pressure difference, the stronger the pressure gradient, and therefore faster the wind. When isobars are closely spaced, the pressure gradient is steep and winds are strong. When isobars are widely spaced, winds are weaker. For example, during a cyclone, isobars are packed closely together around the low pressure center, resulting in very strong winds. So next question, can pressure gradient force alone determine wind direction? No, wind direction is also influenced by the Coriolis force and frictional force. Next question, explain the Coriolis force. Why is it absent at equator and maximum at the poles? So the Coriolis force is an apparent force caused by the rotation of the earth. It changes the direction of moving air but not its speed. So in the northern hemisphere, wind is deflected to the right. In the southern hemisphere, wind is deflected to the left. The Coriolis force is zero at equator because the rotational effect on horizontal motion is negligible here, and it increases with latitude and becomes maximum at poles. For example, the northeast trade winds do not blow directly toward the equator. They are deflected westward due to the Coriolis force. Next question, does Coriolis force created wind? So no, it only changed the direction of wind. The pressure gradient force initiates wind movement. Next question, why are geostrophic winds formed only in the upper atmosphere? So a geostrophic wind is formed when the pressure gradient force is exactly balanced by the Coriolis force. So geostrophic winds developed in the upper atmosphere above 2 to 3 kilometer above the Earth's surface because friction is negligible there. Near the Earth's surface, friction slows down the wind, preventing the perfect balance between the pressure gradient force and Coriolis force. As a result, surface winds cross isobars, whereas geostrophic winds flow parallel to isobars. For example, jet stream flowing in the upper troposphere are close to geostrophic balance because friction is very small. Next question, why do surface winds cross isobars? Because friction reduces wind speed, weakening the Coriolis force. Therefore, the pressure gradient force dominates slightly, causing winds to cross isobars towards the low pressure area. Next question, what is intertropical convergence zones and why is it called a zone of convergence? So intertropical convergence zone is a low pressure belt near the equator where the northeast trade winds of northern hemisphere and the southeast trade wind of southern hemisphere converge. Due to the intense solar heating near the equator, air becomes warm, rises by convection and creates low pressure area. This rising air causes surface winds from both hemispheres to converge. Therefore, it is called the intertropical convergence zone. So, it is a low pressure belt. Air rises due to convection. It is associated with heavy rainfall and thunderstorms. It shifts northward in July and southward in January. Following the apparent movement of the sun. For example, during the Indian summer season, the ITCZ shifts northward over the Indo-Gangetic plain, helping to establish the southwest monsoon. Next question, why is the intertropical convergence zone not permanently located at the equator? So because the overhead position of the sun changes seasonally due to the Earth's revolution and axial tilt. Hence, the zone of maximum heating and low pressure also shifts north and south. Next question, explain the planetary pressure belts of the Earth. So, the Earth has 7 major pressure belts due to unequal heating and rotation. One is equatorial low pressure belt, 2 subtropical high pressure belt around 30 degree north and south, 2 subtropical low pressure belt around 60 and 60 degree north and south, and 2 polar high pressure belt at 90 degree north and south. So equatorial low, it is thermal low and the rising air is found here, heavy rainfall. The subtropical high is a dynamic high and descending air is found here, dry and stable weather, source region of trade winds and westerlies. Next question, next is subpolar low. It is also a dynamic low, meeting place of westerlies and polar easterlies, and frequent cyclonic activity is found here. Polar high, it is thermal high and cold and dense air is found here. Source of polar easterlies is this polar high region. For example, the Sahara Desert lies near the subtropical high pressure belt where descending air suppresses cold cloud formation leading to arid conditions. For example, next question, then why is subtropical high called a dynamic high? Because it is formed mainly by descending limb of the Hadley cell, not directly by surface cooling. Next question, explain the 3-cell model of atmospheric circulation. So circulation is explained by 3-cell models consisting of Hadley cell from 0 to 30 degree, Ferrel cell 30 to 60 degree, polar cell 60 to 90 degrees. Hadley cell, warm air rises over the equator, moves poleward in the upper atmosphere, cools and descends around 30 degree latitude. Ferrel cell, it is an indirect circulation between 30 to 60 degree influenced by Hadley and polar cells. And polar cell, cold air descends over the polar poles and flows towards 60 degree latitude where it rises after meeting warmer air. These 3 cells maintain the Earth's heat balance by transferring excess heat from low latitudes to higher latitudes. Next question, so for example, without the Hadley cell, tropical heat would remain concentrated near the equator, making the climate much more extreme. Next question, why which cell is thermally direct? So Hadley cell and polar cell are thermally direct, whereas the Ferrel cell is thermally indirect. Next question, what are the trade winds called the most reliable? Why are the trade winds called the most reliable planetary winds? So trade winds are permanent planetary winds that blow from subtropical high pressure belt towards the equatorial low pressure belt. Due to the Coriolis force, they become northeast trade wind in the northern hemisphere, and they become southeast trade winds in the southern hemisphere. They blow throughout the year, they are steady and regular, they converge at the ITCZ, they transport large amounts of moisture over the oceans. For example, the northeast trade winds help in transporting moisture across the tropical Atlantic Ocean. Next question, why are they called trade winds? So historically, sailing ships depended on these steady winds for international trade routes, hence they came to be known as trade winds. Next question, differentiate between planetary winds, seasonal winds and local winds. So planetary winds, these are permanent winds blowing throughout the year due to permanent pressure belts. For example, trade winds, westerlies, polar easterlies. Seasonal winds are reverse. Seasonal winds reverse their direction seasonally due to differential heating of land and water. For example, the Indian monsoon. During summer, winds blow from sea to land, and during winter, wind blows from land to sea. Local winds they develop due to local differences in heating and cooling. For example, sea breeze, land breeze, valley breeze, mountain breeze, etc. So next question, why are local winds short-lived? So because they depend on local temperature contrast, which exists only for a short duration, usually during a part of day or a particular season. So the atmospheric, there is gist of this part of this lesson. Atmospheric circulation is fundamentally controlled by differential heating, pressure gradient force, Coriolis force and friction. Together these processes redistribute heat and moisture across the earth and play a vital role in determining global weather and climate. Next question, what is an air mass and how is an air mass formed? So air mass is a large body of air having relatively uniform temperature and moisture characteristics in the horizontal direction. So in an air mass develops where air remains over a large homogeneous surface called the source region for a sufficiently long period. During this time, it acquires the temperature and moisture characteristics of that surface. Air mass form over uniform source region. The source region should be extensive, homogeneous and stagnant. They are classified on the basis of temperature and moisture. On the basis of moisture, is continental, dry and maritime, moist. On the basis of temperature, Arctic, Antarctic, polar, tropical, equatorial, etc. For example, the maritime tropical air mass forms over the tropical oceans. It is warm and moist and often brings heavy rainfall to the coastal regions. Next question, why do oceans produce maritime air masses while continents produce continental air masses? Because oceans continuously supply moisture through evaporation, whereas continents are comparatively dry. Therefore, maritime air masses are moist while continental air masses are dry. Next question, what is a front and explain the different types of front. So a front is a boundary zone separating two air masses with contrasting temperature and moisture characteristics. Weather changes occur mainly along fronts because warm and cold air interact. Cold front, in case of cold front, cold air advances and forces warm air to rise rapidly. In cold front, the weather is cumulonimbus clouds is formed, heavy rainfall occur, thunderstorms are found and sudden fall in temperature is found. In warm front, warm air gradually overrides cold air. Gentle uplift is found here, layered clouds are formed and continuous light rainfall is happened. Next is stationary front, neither air mass advances. There is cloudy conditions found in stationary front, and prolonged light rain is happening due to the stationary front formation. Occluded front, a cold front overtakes a warm front. In complex weather conditions is found in case of occluded front, and widespread precipitation is found. For example, most temperate cyclones develop along the polar front. Next question, which front produces the heaviest rainfall? The cold front, because the warm air is lifted rapidly, causing strong convection and intense precipitation. Next question, differentiate between tropical cyclones and extratropical cyclones or temperate cyclone. So tropical cyclone develop over warm tropical oceans, and temperate cyclone develop along the polar front. No front is found in case of tropical cyclone and temperate cyclone. Warm and cold fronts present, and warm core system is found in case of tropical cyclone, and in temperate cyclone cold core system found. And tropical cyclone is circular and symmetrical, and temperate cyclone is asymmetrical. Tropical cyclone energy form from latent heat release, and in temperate cyclone energy from temperature contrast between air masses. And in tropical cyclone cyclone I is present, and in temperate cyclone I is absent. For example, cyclones over Bay of Bengal are tropical cyclones, whereas cyclones affecting Europe are temperate cyclones. Next question, why are fronts absent in tropical cyclones? Because the temperature over the tropical ocean is relatively uniform, hence contrasting air masses do not exist to form fronts. Next question, why do tropical cyclones develop only over warm oceans? Why are they absent near equator? So there are few conditions to form tropical cyclones: sea surface temperature above 27 degrees Celsius, high humidity, low pressure center, strong convection, sufficient Coriolis force. Warm oceans provide abundant water vapor. During condensation, latent heat is released, supplying energy to intensify the cyclone. Next question, why are they absent near the equator? So Coriolis force is 0 near the equator, since the Coriolis force is essential for initiating the cyclonic rotation. Tropical cyclones generally do not form within about 5 degree latitude of the equator. For example, the Bay of Bengal experiences more tropical cyclones because sea surface temperatures remain above 27 degree Celsius during the cyclone season. Next question, why are tropical cyclones generally more frequent over Bay of Bengal than Arabian Sea? So the Bay of Bengal usually has warmer sea surface temperature and higher moisture availability, creating more favorable conditions for cyclogenesis. Explain the structure of a tropical cyclone. Why is the eye is calm? So central eye is a mature tropical cyclone has 3 main parts. First is eye, cyclone eye. It is a central region. Lowest pressure is found here. Descending air is formed, and clear sky, calm weather. An eye wall surrounds the eye. Strongest winds, maximum uplift, heavy rainfall, and tall cumulonimbus clouds is formed. And spiral rain bands, curved bands of clouds, heavy rain, thunderstorms. So the diameter of eye generally varies between 10 to 100 km, and the entire cyclone may extend over 150 to 500 km. For example, during severe cyclones over Bay of Bengal, people inside the eye experience temporary calm weather. However, after the eye passes, violent winds return from the opposite direction as the eye wall arrives. Next question, why is the eye calm despite being center of the cyclone? Because the air subsides or sinks in the eye. Descending air suppresses cloud formation and rainfall, producing relatively clear skies and light winds, even though the surrounding eye wall experiences the strongest winds and heaviest rainfall. So there is some follow-up questions from what is the source region of an air mass? So a large homogeneous region where an air mass acquires its temperature and moisture characteristics. So there is 4 types of fronts: cold front, warm front, stationary front and occluded front. So what is the minimum sea surface temperature required for tropical cyclone formation? Above 27 degrees Celsius. Which cyclone has a warm core cyclone? Tropical cyclone. Which cyclone is associated with fronts? So extratropical or temperate cyclone. Why are tropical cyclones absent near the equator? Because Coriolis force is negligible near the equator. Which part of tropical cyclone has the strongest winds? The eye wall. What is the typical diameter of an eye of cyclone? 10 to 100 km. So the next question is, what is a jet stream and explain its characteristics and significance. So jet stream are narrow bands of very strong winds blowing in the upper troposphere, generally near the tropopause. They blow from west to east westerly direction with very high speeds, often exceeding 200 km per hour. Jet stream develop due to strong horizontal temperature gradients between different air masses. So it is found near the tropopause, blow from west to east, speed generally 110 to 400 km per hour, strongest during winter, closely associated with subtropical westerly jet and polar front jet stream. Importance: influence weather system, guide the movement of temperate cyclones, affect aviation, play an important role in the onset and withdrawal of Indian monsoon. For example, during winter, subtropical westerly jet flows south of Himalayas and influence the western disturbances, bringing winter rainfall to the northwest India. Next question: why are jet stream faster in wind? Because the temperature difference between tropical and polar region is greater in winter, producing a stronger pressure gradient in the upper atmosphere. Next question: what are the western disturbances and why are they important for India? So western disturbances are temperate cyclones that originate over the Mediterranean region and move eastward under the influence of subtropical westerly jet stream. They enter India during winter season. They originate over the Mediterranean Sea, travel from west to east, associated with temperate cyclone, bring winter rainfall to northwest India, cause snowfall in the Himalayas. Importance: so beneficial for rabi crops, especially wheat and mustard, recharge soil moisture, increase water availability. For example, Punjab, Haryana, Rajasthan and western Uttar Pradesh receive winter rainfall mainly due to western disturbances. Next question: which jet stream carries western disturbances toward India? That is subtropical westerly jet streams. Next question: explain the land breeze and sea breeze with the help of pressure difference. So land breeze and sea breeze are local winds produced by the differential heating and cooling of land and water. What is sea breeze? So during the day, land heats up more rapidly than water, low pressure develops over the land and high pressure remains over the sea. Cool air moves from sea to land and this is called sea breeze. Land breeze: during night, land cools faster than water, high pressure develops over land and low pressure remains over the sea. Air moves from land to sea. This is called land breeze. For example, sea breeze moderates the daytime temperature in coastal cities such as Mumbai and Chennai. Next question: why does land heat up faster than water? So water has a higher specific heat. Water is transparent, allowing solar radiation to penetrate deeper, and water is constantly mixed by currents and waves, and a large amount of energy is used for evaporation. Therefore, land gains and loses heat more rapidly than water. So next question: explain the valley breeze and mountain breeze. So these are local winds caused by differential heating of mountain slopes. Valley breeze during the day, mountain slopes are heated quickly. The air becomes warm, expands and rises along the slopes. This upward movement is called valley breeze. And mountain breeze during the night, mountain slopes cool rapidly. Cold dense air flows down slope into the valley. This downward movement is called mountain breeze. So valley breeze is common in Himalayan valleys during sunny afternoons, while mountain breeze occur during clear nights. Next question, which breeze is associated with cold air descending? That is mountain breeze, because cooled air becomes denser and flows downhill under gravity. Next question, how does atmospheric circulation help in maintaining the Earth's heat balance? So the equatorial region receives a surplus of solar energy, whereas the polar regions experience a deficit. If this imbalance were not corrected, the equator would become progressively hotter and the poles progressively colder. Atmospheric circulation continuously transfers heat from tropics towards the higher latitudes, helping to maintain Earth's energy balance. This redistribution is achieved through planetary winds, Hadley, Ferrel and polar cells, jet streams, cyclones and anticyclones. So what is significance of this atmospheric circulation? So it maintains global energy balance, regulates weather and climate, redistributes heat and moisture, supports the global hydrological cycle. For example, the westerlies transport relatively warm air towards higher latitudes, while polar easterlies move cold air towards lower latitudes, helping to balance temperature difference. Next question, what would happen if there were no atmospheric circulation? So without atmospheric circulation, the equator would become excessively hot, the polar regions would become extremely cold, heat and moisture would not be redistributed, the present global climate system could not be maintained. So there are some factual questions from this chapter. Standard sea level pressure is 1013.25 millibar. Instrument used to measure atmospheric pressure, that is mercury barometer or aneroid barometer. Which force? So next question, which force initiates wind's movement? That is pressure gradient force. Which force changes wind direction? Coriolis force. At which latitude the Coriolis force is 0? In equator 0 degree. Name the three cells of global circulation: Hadley cell, Ferrel cell and polar cell. What is ITCZ? It is an low pressure zone where northeast and southeast trade winds converge. Which pressure belt is known as horse latitude? So subtropical high pressure belt around 30 degree north and south. Which winds are called permanent wind or planetary winds? That is trade winds, westerlies and polar easterlies. Minimum sea surface temperature required for tropical cyclone above 27 degrees Celsius. Which cyclone has a warm core? That is tropical cyclone. Which cyclone develops along the polar front? Temperate or extratropical cyclone. Where do western disturbances originate? At Mediterranean region. Which jet stream influence western disturbances? That is subtropical westerly jet stream. Which local wind blows from sea to land during the day? Sea breeze. Which local wind blows from land to sea during the night? Land breeze. Which breeze moves up slopes during the day? Valley breeze. Which breeze moves down slopes during the night? Mountain breeze. Which layers contains jet stream? That is upper troposphere near the tropopause. And this is the last question for today. Why is atmospheric circulation important? So it redistributes heat and moisture and maintains the Earth's global heat balance. So thanks for listening. Keep listening for further audio classes. Thank you.